Okay, so good day everyone. This is a part 2 of 3.2. We'll be discussing about parallel and perpendicular components of acceleration. Okay, so let's start. Let's say we have a motion curve with the point P. Okay, let's say this point P is an axis. Okay, so we have a perpendicular and a tangent line on our point P. And let's say this point P is a particle that moves with a velocity and has a acceleration of a. Okay, so in this lesson we will be discussing about the two components of acceleration vector. We have your parallel, which is parallel to the velocity, and we have your perpendicular. Okay, so in order to fully understand these parallel and perpendicular components of acceleration, let's recall one of our examples from 3.2. Okay, so we have this car. Okay, so we have point 1, velocity 1, point 2, and velocity 2. Okay, they have the same direction in a straight line, horizontal line. How about we get the um, diagonal. Okay, so will it still be the same? Okay, they still have the same direction, but will the direction of acceleration change? So let's get your V1 and also your V2. Okay, they are small figures, so let us enlarge them. Okay, so this will be our change in velocity. Okay, so that is V2 minus V1. That's the change in velocity. From our first example in 3.2, from our example in 3.2, the change in velocity, the direction of it is also the direction of our acceleration. Okay, so in this figure, can we say that we have the parallel and perpendicular components of acceleration? Okay, so I think we only have your parallel acceleration. We do not have the perpendicular acceleration since the velocities are in the same direction. Also with the change in velocity. Okay, so let's bring back our figure from before. Okay, and take out all the unnecessary objects. Let's say this particle is a ball. Okay, a ball thrown with the motion curve. Okay, a ball thrown following the motion curve with a velocity v. This velocity v is the velocity of the ball in the direction where wants to make the ball move away from the motion curve, or it is our tangential it is the velocity that is tangent to the motion curve. And we also and also let's label this as your v1. Okay, so we have another velocity acting, or we have another velocity on this ball. We have a velocity that follows the direction of our motion curve, which is your velocity 2. Okay, so we have two velocities here. These velocities have the same magnitude but differ in their direction. Okay, so one that is trying to make the ball fly away or move out of orbit, and we have the second one that is moving along the orbit or the motion curve. Okay, so let's get your V1 and let's also get your V2. Okay, for illustration purposes, let's enlarge them. So our change in velocity is this. Okay, so at first glance, you can assume that the direction of our acceleration is perpendicular to V2. Okay, so let's see if you're correct. Okay, so the acceleration with the direction is the same with the direction of our change in velocity. But why is that? Okay, So our V2 here, class, if you can recall, the change in velocity is equal to V2 minus V1. That is final velocity minus initial velocity. So that means our V2 is just the change in velocity plus the initial velocity or your V1. Okay, but since I told a while ago that velocity 1 and velocity 2 have the same magnitude, since V2 is equal to V1, this change in velocity can only be depicted by V or its direction, right? So there is no change in magnitude, but there is change in direction. Okay, so when there is a only change in direction, okay, the direction of our acceleration is perpendicular to the velocity or perpendicular to the motion curve. Okay, so let me give an illustration of this. Okay, so we have your checklist. We have the parallel and the perpendicular. So we only have your perpendicular here and we do not have the parallel. Okay. Okay, so that is the motion of our ball if we throw it according to the motion curve. Okay, so let's take a look at it again. It moves along the motion curve. Okay, so we during this motion, we're going to talk about the circular or the curvilinear motion. Okay. So when the motion has a tangential acceleration and when the motion has a normal acceleration. So I'm going to explain about those two, the curvilinear acceleration.